absolutely the highest point. So as soon as you know your highest point, you'll know where your y's go. That's why you can always find your domain first through restrictions, but you can't always find your y, your range, until you get your points for your turning and everything else. You guys okay? All right. F of 0, if we plug a 0 in here, you're looking for when x is 0. What is the y? The y is 1. The second one, number 8, all real numbers for both. Good. Is this an absolute or a relative? A relative max. And what about this guy down here? Relative min. Because this min goes on and on. This max goes on and on. There is no absolute max nor absolute min in this one. They're relative to that spot. Now, the nice part is we can find them. We can see them on your graph. We'll find them in your table as well. And then we'll look for them in different ways. So those are the things we're going to be looking at today, describing these things. All right. Number 9, your domain is restricted from -4 to +4. And your range only goes from 0 to 4. This is part of your circle. This is where you get the radical with the quadratic underneath it. That's part of your circle. And that's where you get your restriction from there. Would you consider this an absolute or a relative maximum? Absolute. It's absolutely the highest point. And would you consider this an absolute or a relative min? Absolute. It's absolutely the lowest point on your grid. Good. Now the second one, this is like your piecewise that you just did. This is your piecewise. Remember we were looking at these in the very beginning, finding its domain, finding its range? And I said when we get to piecewise, you'll kind of see where they come from. Here's your pieces of graphs. There's one piece that's a line. There's another piece that's a line. So if you found your equation, you know this domain goes from -infinity to 0, open circle. This one goes from 0 to infinity. So your domain is all real numbers. It covered everybody. Now, your range, check your y's. All these y's are continuous. They go up forever. But nobody goes lower than this. Is that an absolute or a relative? Absolute. That's an absolute min. Good? Okay. Today, we're going to go on with describing these things. So, you know the sheets you had from yesterday? We're going to be using those today. Those right? Sure. Those down? Just in case. Just in case you happen to see them again.
Use them for examples.
Examples, there you go. So that's the homework. All right. Hopefully, we get to this today. Okay, we talked about your odd and evens. Now we're going to do a sketch and describe. We're going to find all these things for this. So the first thing I want you to do is to put this in your calculator. Put this in your calculator and sketch. Just watch the wire, guys.
You know?
From yesterday? Yeah, probably in the Thursday one. have this from yesterday, right? Okay, I need all talking to stop. Everybody has to stop talking. Do a regular breath. Now, kind of get the hang of this, right? This should make what? You should see upside down parabola because A is negative. You see the descending, the highest is 2. So your parabola is kind of going like this. Somewhere, right? It's a little tough to tell right here. So the first thing we're going to do, unfortunately I don't have a calculator on this computer, but I'm going to show you how to zoom in without zooming. We're going to change your window for a minute. So go to your window, hit window, hit the word window, and let's do your X max from -2 to +2, and your Y min from -2 to +2, and graph. No, but I want you to put in -2 to +2 on both. So now we kind of get a better look at this. Go to window, go to X min -2, X max +2. Okay. So everybody sees where it's turning? Okay, keep it on that window for me. Now, this point right here, well, let's hit your domain. What's your domain for this? All real numbers. Good. All real numbers. Range we don't know yet. Why don't we know the range yet? How come we can't tell the range by looking at this? It's a sketch, but what do we need to know? The point. And what is that point that we're looking for called? An absolute maximum. So I'm looking for its absolute maximum point. That will help me get the range. Now, I kind of look at my sketch here, and I can't really tell by looking at this. So follow my directions. We're going to find it. I want you to go second trace. Second trace. You should get a screen that says calculate. Right? I want you to come down to number 4, maximum. Now, see that little bugger thing that's lit up, that little flasher thing? I want you to use your left arrow and scroll. Make sure it's to the left of the maximum point. As soon as it's to the left, hit enter. Then scroll with your right arrow to go to the right of that maximum point. When it's to the right of that maximum point, hit enter. And you're going to use your arrow to scroll to the left. You're going to use your arrow to scroll to the right. You're going to hit enter, and then it says guess. You're going to hit it again. Can everybody do that? I'm sorry, but this doesn't have a calculator that I can pull up there. I'm sorry? It goes down? Yeah, but I want you to find the maximum point. It's just not left down. Stay here. Yeah, I'll write it down. You have nothing in your y equals, so you can't have a graph. Okay, guys, listen carefully. Go to your graph. I need all your conversations to stop. Okay, go second trace. Number 4, maximum. We're going to be using this a lot, so you might want to write this down. Now, use your left arrow key. See your left arrow key over here where the 4 keys are? Use your left key, left arrow, until that little flasher guy is to the left of this maximum point, and hit enter. Now it says right bound. Use your right arrow key and move it to the right, anywhere to the right of that maximum point, and hit enter. Now it will say yes. Hit enter. Now it will find your maximum. What you did was just locate where your maximum point is, because there'll be other graphs where we need to find more than one relative max. So we need to isolate it. Instead of using your arrow here, you could put the value of x in there. You could say from 0 to 2, find me the maximum point between those two x's, and it will find it. It's far easier just to scroll to the left, enter, scroll to the right, enter. You don't have to worry about what x values you're looking at. Now, that's going to give you this point, 0.5, 0.25. Does everybody get that point? Okay, that's your absolute maximum point. Now, you know your highest y. Yes. To the right, and it says yes, and enter. Left arrow, left arrow. My board is so off every time. Every time I touch the computer, my board goes off. Half the time it stays blinking, so my things don't come out. I'm sorry. I'm trying the hardest I can here. So now let's get your range. Negative infinity, and what's the highest y that it goes to? 0.25. Here's your range. Can you use 0.25? Yes. Okay, so now we found your range. Now we're going to find your increasing segment. Your increasing says, I want you to tell me as x is moving from the left to the right, is y increasing, or y decreasing? So this is like a roller coaster. So we come from down here, we're increasing, increasing, increasing until we hit this point. So to tell me an increasing interval, you have to tell me the x value. I don't want the y. I want to know when x is going this way, it keeps increasing until I hit this x point, and then it stops increasing. Remember, what's increasing is y. That's the value of your function. Let me tell you what value it is if we know what x we're looking at. So all of these, we give the x intervals. So we're coming from negative infinity, and we're stopping at 0.5. And we always put these in soft brackets, because if you watch, when we decrease, we start at 0.5, and we go down. So they're kind of sharing 0.5. That's its maximum point. Almost picture it like at a point at the top of a mountain. You increase till you get up to your mountain, then you decrease, you come down. So your decreasing portion is this guy right here. Again, you read your x's as it goes from here on out. So it's decreasing from 0.5 to infinity. You're tracing your y, so it's looking like a roller coaster. We're looking at the value of y, but we're reading the x. And we read x from left to right, from the negatives all the way through to the positives. This is one of the toughest concepts to get, and it takes kids a while to give me the x values. They give me the y values. You have to tell me where is x making the value of your function increase. Where is x making the value of your function decrease? That's what we're looking at. That makes sense? I'm not going to scroll mine, I'm just going to go to the intercepts. We need to find an x-intercept, and we need to find a y-intercept. Now, if you remember, to find an x-intercept, these guys, what's the value of y? 0. So we're going to take this and plug a 0 in. Remember, we find these algebraically. And we factor. So what can we take out of this? A negative x. And what's left? X. Minus 1. Okay. Set these equal to 0. So x is equal to 0, and x is equal to 1. Here's your x-intercepts at the 0, 0, at the 1, 0. And go to your table. The second table table and see, is it at the 0, 0? Is it at the 1, 0? You can confirm this on your calculator, but you have to find this algebraically. Good? Okay. Let's do your y-intercept. On your y, I know we found this, but on your y, what's the value of x? 0. So let's take your equation and plug in a 0. So y would be 0, and we knew that already, but we have to solve this algebraically. Okay, question? Question? No? Because these are tough. You have to solve them algebraically. I know they're obvious, and everybody says, well, you can see it's right there. I can see it on my table. But you have to solve them algebraically, confirm them graphically. Okay? Good? And the last thing we want to do is we want to tell if this is odd or even. We want to see if this is odd or even. And what do we do to tell if it's odd or even? John? If it reflects on the y, so is it reflecting over the y-axis? No, so it's not even. If it's odd, it's going to reflect through where? The origin. So is it reflecting through the origin? No, but now we have to show this algebraically. So we say, take the x and substitute in a negative x. As my boy behaves, we will substitute in a negative x. So take this, substitute in a negative x, substitute in a negative x. We want to see if we come back to the same one, it's even. If every sign is different, it's odd. So we take this like this. So we say negative of negative x squared plus negative x. This will still give us negative x squared, but this guy's going to say minus x. So we look to see, is it the same as the original? No, it's not even. If I factor out a negative 1, God bless you. If I factor out a negative 1, is it the same then as the original? No. So it's neither odd nor even. And Jonathan confirmed it by looking at it to say there's no reflection over the y-axis. There was no reflection through the origin. So even though you're looking at your graph and you can tell like this, you're going to solve it algebraically. Another way to look, and when we get to an odd one, I'll show you on your table. You actually can take one of the points. Like if it's 3, 2, there'll be a negative 3, negative 2 in your table as well. You can kind of tell by the points. Because your rule through the origin is negate both of them. So you can kind of see it on your table as well. Good with this one? Alright, let's try another one. Okay, put this guy in your calculator. Please. And again, the nice part is we just draw a sketch. That might be even if you see a reflection over the y-axis. Maybe not. So it's looking like, as we sketch, we just got to go like this. And a good sketch kind of looks like this. It's probably not as deep over here, right? What does yours look like? I think you did, yeah, I think you got to go back. Go do a zoom 6. Do a zoom 6 on yours because we changed your screen. It looks like that. Do a zoom 6. You did?
Oh.
Okay. All right.
That's why it looks
Zoom 6. What happened is I zoomed your screen in. I zoomed your screen in, guys, to do 2 to negative 2. Because I wanted you to see where it was crossing. I wanted you to be able to see we couldn't see that maximum point there. But just do Zoom 6. That brings you back to a standard screen. Okay. What's the domain for this function? All real numbers. Hit the word zoom. Hit the word zoom 6. What's the range for this? All real numbers. Does it have an absolute maximum? No, it keeps on going up and up. Does it have an absolute minimum? No, it keeps on going down and down. No absolute. Does it have a relative maximum? Okay, let's work on its relative maximum. So let's label A, B. Which one is, it's easier to label all your points that you need to label with letters, and then you can just fill them in on the side. Is A or B the relative maximum? A. So let's see if we can find that. So again, you're going to go second trace. You're going to go down to number 4. You're going to scroll your arrow to the left of this guy. Then you're going to hit enter. Scroll to the right, hit enter. And then you're going to hit enter again where it says guess. We're going to use these. Go to second calc. Number 4. That little cursor thing, that little flasher thing. You want to use your left arrow to isolate this. Look what we're doing. Your calculator is going to give you these little marks like this. It's going to isolate this point. If you isolate any particular area like this, over here, it's going to find the maximum point for that. So you have to tell it, I want you to look right here. I want you to look here and tell me what's the highest point of just this piece of crap. So what did it give you? 2. So what's the point? For this guy? What does it say? Okay, watch. It gives you this. Watch this E thing. What does E mean? E to the negative 7 mean? It means your exponent is to the negative 7. Which way do you move your decimal place? To the left. So what is this value? 0. Your calculator does these different things. Sometimes with a 2, it'll say 1.99999. It is really, really, really exact. If ever it gives you an E to the negative anything, it's moving your decimal. If you put 6 zeros out here, isn't that the same as that's like 0? So the point is 0, 2. The calculators do these really crazy calculations on them somehow. Okay, if I need to find my relative min, the same process, but now when you do second calc, what are you going to put in? 3 minimum. So let's try that. Do a 3 minimum over here. And isolate your thing to the left, hit enter. Isolate it to the right, hit enter. And hit enter to guess. 2, 2. Okay, see if you come up with that. Good? Did everybody find that minimum? Alright, we use the min and the max the exact same way. You could put your value of x in here as well, but because we're sketching, it's generally harder to tell where my x value is. So I like to move the cursor back and forth, but you can absolutely put your value of x in there. Okay, now let's find your increasing. This is my roller coaster. I'm going here, let's put the point up here. This is at 0, 2, and this is at 2, negative 2. My y is coming up here, increasing, increasing, until my x hits what value? What's the x value? 0. So from negative infinity to 0. Do you see any place else where it's increasing? From where? Give me the x value. 2 to infinity. So your roller coaster increasing, decreasing, increasing. So n 2 to infinity. It's got 2 increasing segments. What's the decreasing segment? 0. Oh, give me the x value. 2. So it's going to decrease when x is 0 to when x is 2. The value of y is decreasing when x is 0 to 2. See it? Now, if you kind of watch this, you have your whole domain. Negative infinity to 0, 0 to 2, 2 to infinity. You have your whole domain there. Okay, intercepts. Let's do an x-intercept. So we plug a y for 0 in here. So let's substitute in the 0. You're going to have to factor. Actually, you can't factor this right now. This is not factorable. Well, for you guys right now. So what we're going to do instead is we're going to find, I could factor out your perfect squares, but your perfect cube. But we're not going to do that. Instead, we're going to do this. I'm going to throw something else at you. This is a 0. Right here. These are called zeros. Sometimes, when you factor them, you have to use a quadratic or something else. This, unfortunately, is a... Did you guys learn cubes? The difference of perfect cubes? No? All right, I'll give you the difference of your perfect cubes, and that might be easier. This is x squared minus 2x minus 2. So you're going to set these to 0. This one you're going to have to use a quadratic, so we're just going to kind of let the zeros go on this side. To find your y-intercept, plug your x for 0. So if you plugged your x in here, what would your y-intercept be? 2. Watch how easy this is. When x is 0, y is 2. Just cover it. Holy smokes. This is amazing. I'm probably going to lose this. Okay, and odd or even, we substitute in a negative x. It's not odd nor even. So tonight, for homework, you're going to finish up that homework sheet.